Welcome back to ESIP Winter Meeting, and I agree, that is a beautiful way to start the day. I want to again acknowledge our sponsors, especially our silver level sponsor, SAIC. While we're talking about sponsors, I want to thank AGU for their sponsorship of last night's research showcase. If you missed it, it's not too late. The research showcase is open for the next 2 days, and it's a great chance to connect with others, and I really encourage you to check it out. Last night, I learned about AI professional development efforts at NOAA. I learned about an ESIP lab project on lake levels. I learned how GeoCollaborate is pulling together different data sets to make emergency response coordination more effective. I learned about a Funding Friday Teacher Award using drones and an amazing teacher trying to keep kids engaged in the middle of a pandemic. And I had a really interesting discussion on public-private partnerships and what does that even really mean? Better yet, I had small group conversations with people that I now consider friends. I met new people and I learned new things. And that's what this is all about, right? So if you were there, I would love for you to share in the chat what your favorite posters were. And hopefully that can guide others to do some exploration today and tomorrow if they missed it last night. And I'll say self-promotion is allowed. You know who you are, who tried to guide people to your own sessions. I'm all for that. To continue the networking today, I want to invite you to our coffee break at 3:15, which is sponsored by Element 84. This coffee break will again use the Wonder platform, which I think many of you are enjoying as a way to move around and have great conversations. Element 84 has also created for us some swag, a t-shirt that you can go and purchase, and a portion of those proceeds benefits ESIP. It is a nod to our theme on frontiers and also a little bit of a Star Wars theme that I hope you guys like. So we started on Monday looking at the general elements needed for cultivating innovation and work at the frontier. Yesterday, we got more specific, exploring the frontiers of AI and ML. And yesterday afternoon, we had a great session looking at how do you even know if you're working at the frontier? Today, we're going to dive deeper into innovations in data search and discovery, a topic that I know is near and dear to many of you. And I encourage you to stick around through this evening's session on credit for research artifacts. Before I turn it over to Adam to introduce our next speakers, I do want to give you a preview of tomorrow. I encourage you to stay with us for a strong finish. In the morning, we will have breakout sessions on California wildfires, accelerating AI, science on schema.org, and informatic challenges associated with biological data. To me, that sounds like there is something for everyone. We will then conclude the meeting with ESIP's annual assembly meeting. So after 3 days of technical conversations, this is your chance to really give you a glimpse of ESIP as a whole. We will talk about our accomplishments in 2020, as well as give you a peek into what's coming next with ESIP. We will also have our leadership transitions, celebrate our outgoing leaders, welcome our incoming leaders. And this is also our opportunity to really celebrate our community leaders with our ESIP Awards session. So I really encourage you to join me for all of this. It's really important. Now it is my pleasure to turn it over to Adam Shepard from Woods Hole and co-chair of the Schema.org cluster to introduce our plenary speakers. Thanks, Adam.
Good morning, friends. On behalf of the Schema.org cluster, it's my honor to welcome and introduce today's plenary speakers on the topic of innovations in open search and discovery. Much of our cluster's success is derived from their personal contributions, and we're so excited to hear from them today. So up first, from within Google's open source programs office, our first speaker leads the Schema.org project. He helped create the web standards for sharing data, including vocabularies such as RDF, RDFS, SCOS, and FOF, as well as the Sparkle query language. Our first speaker's talk is entitled Schema.org and Structured Data on the Web, Techniques, Issues, and Opportunities. Please welcome Dan Brickley.
Hello and good morning from London. My name is Dan Brickley. I work on structured data standards in Google's open source programs office, and I'm also responsible for running Schema.org. My talk today is entitled Schema.org, Structured Data on the Web, Techniques, Issues, and Opportunities. And I should say I'm very aware that some people listening to this talk will be entirely unfamiliar with schema.org, while others will know more than I do about how to apply it to earth science data challenges. For the latter group, I plead for your patience as I try first to give a general overview of schema.org, some background on the supporting technologies and initiatives that led up to it, and then we'll dig a little deeper into some of the issues, challenges, and possibilities that I'd like to highlight as we move into 2021. Schema.org is a collaborative initiative that curates an interlinked set of machine-readable schemas for use in web markup, data sharing, knowledge graphs, and beyond. We'll come back to each of these ideas, but this explanation is missing something. It doesn't say why schema.org really matters. It matters because it's used and useful, and it's useful because it's used, and it's used because it's useful. Millions of sites publish it, and millions of search users have a richer search experience every day because of this. So sites have an incentive to publish schema markup because it communicates page-by-page summaries of their content in a way that benefits their users and aids with discovery. I should also say, to me, Schema.org also matters as the latest chapter in a decades-long effort to bring machine-readable data deeper into the infrastructure of the World Wide Web. Schema.org builds upon ideas you'll also have perhaps heard called linked data, semantic web, W3C RDF, or ontologies. And although it shares this background of all these initiatives, I think Schema.org has so far had the biggest impact on the everyday lives of mainstream web users and web content. Okay, so this is Schema.org. Schema.org is a project named after its website, which you're looking at. It's a collection of definitions of kinds of thing and kinds of properties of those things. So I'm showing you here the event page. The event page is the human-facing definition of schema.org/event. There's a parallel set of computer files that say the same stuff in a more computer-friendly form. You can see essentially that there are types and there are properties, and types generally written with an initial capital, properties always with an initial lowercase letter. It's a useful trick because we have several different syntaxes for writing schema.org descriptions. Let me show you the example. We try and make sure that every page has one or more examples. This is an example of a page without schema markup that describes, looks like a music-related event. And then microdata adds certain pieces of code. You can see item type, item scope, item prop come from the microdata standard. If I flip to RDFA, you see something very, very similar. The two standards were related. And then there's a third standard that we added later on in Schema.org's life that's proved to be one of the most popular, and that's JSON-LD. You see the difference between JSON-LD and RDFA, or microdata, is that it's much more compact. It allows you to focus on words from your description rather than lots of kind of computer words like item prop and item type. Okay, so I'm going to just show you what this looks like in a more machine-friendly form. We'll grab that and take it over to an open source tool called the JSON-LD Playground. Paste it in there, and you see it's been parsed successfully into this structure. Maybe the table's a better way to look. There you go. Subject, predicate, object. Something is related to something else. Schema.org's role in this world is to provide the relationship names. In this case, event, image, subject of, start date, and also types like event and music group. I think that's enough of the markup for now. Let's hop to Google. You can see here what Google does with this markup. And Google is just one of the reasons people put the markup in their web pages. I'm focusing on it because my colleagues made this. Let's start at the top. Search Gallery is the page at Google that shows all the different reasons and all the different product features for using schema markup. So I'm scooting through this really quickly. Articles, books, breadcrumbs, Breadcrumbs are the hierarchical structures that we sometimes show. Carousels are image-centric. We have features around describing educational courses, online and offline, reviews, critic reviews or end-user reviews. Data sets we'll come back to later. Jobs and employers, events. In each case, let's take a look at fact check. You can, I think, interestingly contrast what Google say in this documentation to the schema.org materials. We strive at Google never to contradict the schema.org definitions, but we always bring more specificity because this documentation is not about fact checks or events or people or places in the abstract. It's about pages in the web that describe those things and their eligibility for stuff that we've built. So we need to say more clearly here what it is about a fact check that we expect to see to be able to hopefully include it in these features I'm showing you. So we need certain fields. Schema.org has no notion of mandatory. Schema.org doesn't like to tell people that you should do this, you must do this. For a product feature, it's kind of essential to be able to express clearly what that search feature needs to get a job done. So in this case, if we look at the schema markup, there's an example here. As part of the Google infrastructure, we expose some validation tools. The rich snippets testing tool became the structured data testing tool, became the rich results test. And you can see the hierarchical structure of the description reflected into this slightly more abstract and user-friendly representation here in a tiny font. Okay. Over at schema.org, all the definitions are in GitHub. There's a openly licensed repository. We use the W3C schema language, RDFS, with a few tweaks, and the Turtle language to actually write the schemas. So every change to schema.org comes through this process. If you look at the big pile of open issues, there's a lot of discussion, a lot of bug fixing, a lot of debate about improved schemas, and pull requests come in from the community, from implementers, to make the schemas better, hopefully. If I hop to schema.org and look at the release history, you can see here that we are recently on a nearly monthly release cycle. We tend to make changes in the core of schema.org, which are the most settled, well-defined bits of schema. And in the pending area, pending is this sort of status that we give terms that have been added to schema.org that may not yet have been used, or the definitions are still perhaps slightly in flux. We call it pending, both to encourage people to implement, and as a kind of flag that it might change slightly, and if nobody uses it, that it might even go away or be kind of hidden. So we've been incrementally improving these schemas for years now. My job is a kind of editorial role to synthesize the proposals that come in from everywhere and to make sure they're as consistent as possible with the schema designs of schema without slowing everyone down too much. Okay, so I've given a view of schema.org's definitions, its use in Google product features and services. I touched on its history and data model, showing you the markup. Let's take a super quick look at some actual websites that use it. So here's an IMDb page, and here's the view source of the page, and there's the schema markup in JSON-LD. There's the schema markup in JSON-LD in the Google Structured Data Testing tool, which lets you see a slightly more readable presentation of it. Let's move on to a quick survey across the industry, or across some industries. So Google's use, I touched on various things earlier. I wanted to add that it's not always the public web. We've used it in Gmail as well for invoices, bookings for flights and restaurants and so on in your mailbox. Bing have a variety of features that use the markup. Here's their claim review support. They also do the mail thing. So Yandex, the Russian search engine, were a big part of schema.org, especially in the early days. They made a lot of proposals to improve and add to set of schemas. This is a video they've made. I'm not going to play the whole thing. But you get the idea. They're excited about the technology and the approach, and demonstrating it to their audiences that you can have ordinary markup, and you can add something with Schema.org that gives you a lot more context for what to do with a piece of a page. Facebook have used it. I think this is shopping feeds. They also announced support in various ways for the claim review markup. You can even find Amazon Alexa has made some use of Schema.org schemas. There's some details in the paper of theirs. Apple have also announced various bits and pieces of Schema.org support and have been helpful in the open source GitHub project to improve Schema.org in various ways. Hash.ai, I barely know what they do other than multi-agent simulations in minutes. But again, they've been making use of Schema.org, and you can see that the Open Creative Commons license of the Schema.org definitions has let them build this site. Okay, I think let's move on briefly to super quick skim through some of the tools that are out there to help publishers. I'm not necessarily endorsing any of these, they're just kind of examples. So Yoast have put a lot of work into helping people publish schema markup, as have various people around Drupal, Schema app. There's a whole list here of WordPress add-ons that help people with WordPress use schema markup. And I mentioned the Facebook support for the claim review fact-checking markup earlier. This is some work that was led by FullFact, the fact-checkers in the UK, to make it easier for fact-checkers who are on the WordPress platform to publish claim review fact-check markup effectively. Okay, I think at this point let's move on to some different kinds of uses of Schema.org. The notion of a knowledge graph has reached prominence in the last few years. Picking randomly at Springer Nature, they have something called SciGraph that used Schema.org schemas and others to publish a lot of their data under an open license. Data Commons is a project led by Google that publishes a large amount of open data using primarily Schema.org schemas through, again, the same graph abstraction, where they've done a lot of work synthesizing often numeric and quantitative data sets into a unified graph. So they have, amongst other things, a Sparkle interface, Python Pandas interface, and various other abstractions. Ozymandias was a biodiversity knowledge graph announced a couple of years ago. Again, Schema.org with some extensions. And the Bioschemas project, they've been working to develop proposals for extending Schema.org to cover the life sciences and bioinformatics in just a little bit more detail. So adding types around protein and gene, for example. We're seeing some of that markup appearing on a number of fairly large-scale bioinformatics sites, and there's a directory here. So what we got? Gene, protein, and so on. Let's move on quickly to software. So all of this is no good unless you do something with it. At Google, we have our own software stack. There's a lot of stuff out there open source. One, I'm going to say mistake some people make is to generate code from particular Schema.org releases. But given that we are releasing Schema.org on updates on often a monthly basis, this can easily leave you lagging behind. So some of my colleagues released a Java library based on an old version of Schema.org. That is something we're deprecating. Here you can see a Perl library, again based on a particular release. These can be useful, but it's a maintenance challenge. This is the JSON-LD library that we saw earlier powering the JSON-LD playground. It's great if your markup's in JSON-LD. There's a Ruby library for JSON-LD, And what you increasingly see is a package of multiple parsers, so JSON-LD plus RDFA plus microdata with a common abstraction, typically based on RDF. So Python users have that from RDF-lib. Java users have that from NE23. If you're working in a JavaScript environment, there's equivalently a framework called RDF.js that gives you a lot of the same kind of facilities for JavaScript. I only have a couple of minutes left, so I'm going to try and scoot up the stack quickly. We're seeing tooling that can support working with Schema.org data, often built on or refined from the RDF tools that are out there. Schema here is a toolkit made by Google intern, Anastasia Bievsheva, who created a validator, Schema on the RDF.js and related JavaScript libraries recently mentioned. It creates a validation framework that looks a lot like the Google Structured Data Testing tool, but unlike it, its notion of validation comes from the open standard shackle and checks, which I don't have time to describe now, but they are well documented and there's a whole book about them. So moving along, the structured data linter absolutely deserves a name check, and there's work to improve its user interface going on recently. Every Sparkle store that's out there is very pertinent to the Schema.org story. We have tools like BMuse from the BioSchemas community. Your own Doug Phils and colleagues have been working on Gleaner and related tools. The emphasis here on Docker is interesting. There's a kind of paradox with Docker in that it's very easy to get a dozen different graph stores from Docker. It's very easy to find with Schema.org and other open data sources vast amounts of data that could be published and queried, navigated, and explored in those Docker package tools. But the bringing together of the data and the software, I think, is relatively immature. So if I had to pick some hot topics for 2021, I would say the shape languages that I alluded to. The move from page-by-page use of Schema.org to site-by-site or large graph by large graph. The idea that Schema.org is really all about describing things, and whether it's in one page or one big feed for a whole site is relatively secondary. And I think for large public sector open data sites, you may more effectively publish a Schema.org in a huge feed rather than thousands and thousands of individual pages. I think that the final point I want to make is that the healthy ecosystem of reasons to publish things and tools that make use of the data that's out there, I think, is just the beginning. That we've seen it used in mainstream search contexts, and the model that we have with Schema.org is rich and ripe for extension to other areas. I think there's all kinds of interesting things going on. There's work at Wikidata around subsetting. There's work at the Data Commons project to bring quantitative measures into this environment. It's a very interesting time to be working with these technologies. I've realized I've focused almost entirely on the basics of Schema.org, so I'm happy to take questions and follow up by email or Twitter or whatever to go deeper into any of these topics. So thank you for your time.
Great. Thanks for that talk, Dan. And what we're going to do now is jump right into the next talk and then host a Q&A afterward. But I want to direct your attention to our Q&A application called Slido. So if you're in Kiko Chat and you're in the plenary room, you'll notice 4 sections at the top: announcements, Sketch, 3 takeaways, and then Slido. So if you click that Slido, and you'll find a link in the chat there. If you're looking in Zoom, you'll find a link directly to the Slido. You can enter your Q&A questions there and they can get upvoted. So after our next speaker's talk, we'll open it up and have a Q&A that'll start out moderated, and then we can open up to the floor. So let me introduce our next speaker, who is a senior staff scientist at Google Research, where she works on making all this structured data accessible and useful. She leads the team building Dataset Search, a search engine for all the data sets on the web. So just not our geoscience data sets, but that includes all data on the web, or data sets on the web, rather. So prior to joining Google, she worked at the Stanford Center for Biomedical Informatics Research, where she made major contributions in the area of ontology development and alignment, and collaborative ontology engineering. She's also a fellow of AAAI and has served as the president of the Semantic Web Science Association. Her talk is entitled Building an Open Ecosystem for Dataset Discovery. Please welcome Natasha Noy.
Where I lead Google Dataset Search. Good morning. My name is Natasha Noy, and I'm a research scientist at Google Research, where I lead Google Dataset Search, our tool for finding datasets on the web. So my talk today, Building an Open Ecosystem for Dataset Discovery, is based on what we have learned about the components involved here when building dataset search, but more important, when interacting with dataset providers and dataset users. And I'm giving this talk after Dan Brickley's talk on Schema.org, so I'm assuming you already have some background on some of the standards and some of the ideas that I will mention. So the nice thing about the Earth Sciences community is that I don't need to explain this acronym to anybody. I'm sure all of you know this, and you know what FAIR means and know about FAIR data. In fact, Earth Sciences and Geosciences are arguably at the forefront of making data findable, accessible, interoperable, and reusable. So our work in dataset search focuses on this bit, on making data findable. This is not a new problem. And in fact, data sharing is not a new problem and not a 21st century problem. In 1695, Sir Isaac Newton was reading a paper by John Flamsteed, the Royal Astronomer, and was quite unhappy that the paper only contained the compilation of the observation, but not the observations. Newton and Flamsteed exchanged several letters. Ultimately, Newton got very exasperated, writing to the Royal Astronomer that these and all your communications will be useless to me unless you can propose some practicable way or other of supplying me with observations. I want not your calculation, but your observations only. This is the sentiment that almost half a millennia later, we can probably still relate to. When we read a paper, when we have the summary, and we have a figure, but we don't actually have the data. Probably, but we've gone a long way somewhat, or at least arguably a long way. We have the web, we have ways to publish data. So if before we had to be writing letters to each other, we have the infrastructures, and Dan has talked about it. We have a lot of infrastructures to actually make the vision where data that comes out of our research is easily available to others. Even though we have the infrastructure, one of the most common phrases is still not unlike what Flamsteed would have probably put in his paper if he were to talk about this. Data is available upon request. About a year ago, we did a small study of papers in Nature Materials, which, as all Nature journals, requires a data availability statement. And it turned out that in 93% of the papers in 2019, data was available only upon request from the authors. The situation has changed, and in fact, the Nature Materials example is probably one of those that shows how much publishers and funding agencies can do about data sharing. Indeed, at the same time that we published this study in Nature Materials, the Nature Materials editorial said that data available upon request will no longer be the allowed default data availability statement. And while we don't have the numbers, I was actually looking at Nature Materials just recently for the second half of 2020, and the situation has changed drastically. Similarly, funding agencies such as NSF, which of course funded a lot of ESIC research, National Institutes of Health, Many of them are coming out with recommendations, with guidelines for peer reviews, for panels, that data availability statements have to be better than data will be available upon request, or data when I have finished working on this grant will be on the web page of my lab. And this is the part that I actually want to talk about for the next few minutes, what it means in this context, in the context where we are today, what it means to actually make data available. So, and there are three components here that I would like to discuss. One is what are the best practices and what are the kinds of questions that we need to think about when we're publishing other research about publishing data. Publishing, just making that data somewhere available to someone is not enough. How to make it discoverable, and that will resonate quite a bit with the other talk in this session. And then I will talk about, once the data is actually available and discoverable, how can we make the user's journey easier? How can we enable the users to discover, organize, and search that data? And I'll go through these three elements in order. So, publishing data. Many of us, and I'm sure all of you in this session, produce the data as part of our research, probably produce some new files somewhere, mostly daily. So the first question that we need to think about, and probably that doesn't have a completely straightforward answer, is what to publish. Not every table and not every data set that's on your laptop needs to be available on the web. So the part of the obvious answer is, if we're publishing, say, a scientific paper, then obviously the data that supports that paper, the data that makes the results in that paper, enables others to replicate the results in that paper. That's something that should be published if possible. There are always, of course, concerns of, for example, some data that might have personally identifiable information, or some other reasons why, or data might be proprietary. So there could be some other reasons why one wouldn't choose to publish data, but the default should obviously be anything that's, we want to support our publication as publishing is, should be available and discoverable. Another question that I think is coming up more and more often, and has been coming up in some other contexts, such as government data, and in fact, such as some of the earth science data, some of the data that's extremely useful for others to find is not necessarily directly related to publication. And in some sense, we maybe need to switch a little bit how we're thinking about data and data sets and treat them as first-class objects. While some data is actually supportive of a publication, data does and must exist in its own accord, obviously with all the metadata and all the descriptions. Think of, many of you dealing with things like sensor data from various, from a ship somewhere in the Atlantic, or in a different context, all the data that governments are publishing about COVID or vaccination or testing. So a lot of data could be useful in some other context and not necessarily as part of their publication. So detailing that a bit is helpful. And then with that comes the issue of credit, right? Because we know that when we publish papers and when the data is associated with a data set is associated with a paper, the authors get the credit through, say, paper citations. So we need to, as we're trying to create the ecosystem where data is a first-class citizen, credit and data citation by itself becomes an essential part of that ecosystem, because those of us who create the data should actually be getting credit for that, even if there is not a single paper that is associated with the specific data set. In order for that to happen, so that we can actually cite the data, another important component is that data must be essentially referenceable. And we must have persistent dereferenceable identifiers. So and both of these are important. And what I mean by persistent is, think of when you publish a data set on your own website, on the website of your own laboratory, and then you move somewhere, or the organization of the university web structure changes. That data set is, when it's referred by its own, by URL, that URL changes. It makes much harder for anybody to even cite the data set or to find that data set later. which is why things like digital object identifiers are critical, or any type of referenceable identifier. DOI is one example that we use too. There are other schemes like identifiers.org that allow you to move the data set and to move where the data set is physically located and just to reference it. And so then all the citation and all the reference to the data can just point to the new place. So when we're thinking about publishing data that we may have lying around, these are the two kind of aspects that I think are important to think about. What are the units of data that need to be shared for various reasons, and how to make them citable and how to give them identity on their own as first-class citizens, how to give them their own passports, if you will. So, which brings us to the next idea of making this data discoverable. So just dumping data somewhere in a repository or putting it somewhere in GitHub by itself doesn't actually make the data discoverable. It needs to have several other components. It needs to have metadata. And it needs to be in a use web-friendly standards. Again, sort of, I will refer you back to Dan's talk, but things like schema.org, things like sitemap, things like we live on the web. And right now the information lives on the web. And the web is the primary way in which we disseminate information. And so using web standards is critical here, and working on to extend the web standards so that, for example, the earth science data is well represented is important. And then providing with the data sets, providing metadata for things like provenance, for things like where did the data set come from? How was it collected? What were the measurement techniques? What were the instruments? Possibly what is the suggested usage, in particular, say in the context of data fairness, what is the representation of the data, representativeness of the data? And then data often doesn't live on its own, right? It has links to code that generated it. It could have links to code that uses the data. It could have links to, say, machine learning models that were trained on the data and so on. And so there's a balance here between, and I'll talk about it a little bit more as I switch to talking about data set search, but there's a balance here between kind of providing as much information as possible, sharing as much information as possible, but still doing it in a structured, standards-based way that other tools and products can understand it. So it doesn't always take a human to read it, although some of that will obviously be intended for a human. And so with that, I'm going to the third part of those steps in kind of making data findable, is discovering, organizing, and searching for data. And that's why I want to talk a little bit about our, for those of you who don't know about data set search, just give you a quick glimpse of what it is, and then talk about some of the new things and some of the things that we have done in sort of studying the data in data set search itself. So dataset search is the product from Google available at this URL. And I'm sure all of you are familiar with Google Scholar. So think of this as Google Scholar, but for datasets. It's a search engine. You come to the search engine, you type in a search string, and you get a list of datasets as a result. Again, similar, all of you have used search engines in various configurations. And when you click on a result, what you get to see is a set of metadata. So I've already talked about metadata about a specific data set, from who provides the data set, when was it updated, possibly different places where the data set is available. The description of a data set is spatial, temporal coverage, and then the big sort of blue button to take you to where the data set is originated. And so dataset search is really, and very emphatically, a search engine. It's not a host. We're not hosting data. Our goal is to tell the users where the actual data is. Because a lot of that metadata that I talked about earlier, depending on the domain, depending on the type of data, the different aspects of this metadata that make sense. And we believe that sort of ultimately all domain-specific repositories are the ones that can provide that domain-specific view. So the goal of dataset search is really to take it to where the data is. Some of the more recent things also to give, I mentioned that data should be cited. So we're in addition to the metadata, you can get things like how to cite this data set, ideally with something like a DOR. Just a couple of minutes of how dataset search actually works, because I think it kind of plays into the idea of this open ecosystem. So we rely on the Google crawl, basically any crawl out there that can also do the same, which as it encounters the web pages and processes the web pages, extracts schema.org tables, essentially what Dan has talked about. And then we take all of these tables, we take all of this metadata, and which comes from thousands of domains and millions of data sets, and then we put it together. And we put it together in a number of different ways. First, we clean it up by reconciling, normalizing, basically making sure that the tons of idiosyncrasies that actually appear in the original data that we get from data providers are normalized and made useful for our users. So Google has a knowledge graph, which has a lot of information about places, organizations, things, licenses, people. So we try to reconcile what we can with the knowledge graph. So for example, if a data set has a spatial extent, has spatial coverage, we'll reconcile it with the locations in the knowledge graph. Or if it's provided by a particular organization and that organization is in the knowledge graph, we'll link it to the knowledge graph. And we also try to link data sets to Google Scholar. When we can find mentions of data sets in papers, we link those mentions to the data set. So as of today, actually this study was done about last spring, so it's almost a year ago. At the time, we had about 28 million data sets from 3,700 domains. And I want to spend a couple of minutes just to give you a flavor of what these 28 million data sets are. So we know that this is just a fraction, although we don't know what size of a fraction it is of all the data sets on the web. But because it's based on the crawl, it's reasonably representative and comprehensive in that anything that has schema.org data set descriptions on them is in this corpus. If we look at how many data sets are in each, we get from each domain, we have something we see in many other types of distributions. It's very much a power law. So the top 10 domains are responsible for 65% of data sets in the corpus. And then the other 3,700 minus 10 are responsible for the remaining 35%. And many of them have just a few data sets. We try to identify the topic that the data set covers. We do this automatically by sort of trying to understand the web page, trying to understand the keywords. And the two largest topics are social sciences and indeed geosciences. I mentioned very early in the talk that earth sciences and geosciences are definitely at the forefront of making data fair. And this is kind of a very clear sign of that. So another kind of set of statistics probably less happy set of statistics I want to highlight is I mentioned that having persistent referenceable identifiers is critical in making data citable, but we found that only 10% of the data sets in our corpus have these types of identifiers. On the bright side, we looked at licenses and how open the data is. And while only a third of the data sets actually specify a license, and of course, if you want to make your data accessible, particularly interoperable and reusable, having a license is extremely important. It's much worse to have the most restrictive, it's much worse not to have any license than to have the most restrictive license. But the interesting thing, and perhaps somewhat unexpectedly, of all the data sets that actually specify a license, the vast majority of them are free for either commercial or non-commercial use. They're basically open data, which is great news. And only 10% actually require a fee. And then the small blue sliver there are the ones that are available for free for non-commercial use. So in a sense, if the authors bother to specify the availability of the data, they mostly make it available for free. So to wrap up, what's next in making data friendable, accessible, interoperable, and reusable? Well, there are lots of interesting challenges, and I usually divide them into social and technical challenges. And in some sense, I would argue that social challenges are almost harder than the technical ones. And maybe something that we can discuss in the remaining part of this hour is kind of the issue of incentives. I talked, excuse me, I talked earlier about having publishers and funding agencies encourage scientists to publish data, but what are the good incentives here? What would it mean to share data in a useful way, right? It's not enough to just dump it somewhere. And then the technical challenges, they're mostly sort of computer science challenges here, things like determining the ranking of the data, figuring out the provenance of the data automatically, improving the quality of metadata, and similar kinds of questions. So these are all interesting questions. I think for the non-computer scientists in the audience, or the kind of the social challenges are probably, there might be technical solutions to the social challenges, but these are the ones that I think are particularly interesting. And with that, I would like to thank you for attention, and I'm looking forward to the discussion. Thank you.
Great. Thanks so much for those video recordings, Natasha and Dan. We really appreciate it. Over the course of those talks, we were getting some really interesting questions, some really in-depth questions, and then also some really philosophical strategy questions. So let me, please, so encouraging everyone to go to Slido and put those questions in there so we can get your thoughts brought up to Natasha and Dan. So we'll open it up here. Let me ask the number one question here, and maybe this is a question for Dan, and maybe to incorporate it and bring it up to a more broad level, I'll ask Dan, what's the most successful pathway to engage Schema.org in its development when relationships are not yet in Schema.org? And this really revolves around the first question, or the highest voted question, that asks, we'd like to see variable measured move from pending to active. It's important for describing data sets. So just curious there on that process and how that might move.
I think the main thing to emphasize is using the data. We're kind of wary of Schema.org becoming this gigantic hosting service for everybody's great ideas for schemas. The world is big and complicated, and we could always add more and more. We could always go into more and more detail. So we've tried to, wherever possible, just focus on things that are getting used, things that are getting consumed. At which point I kind of peek over at Natasha. I'm inclined to ask if variables measured is getting used in the sense of consumed.
Yes, it is actually. We do if the metadata specifies variables measured, dataset search does pick it up, and it actually does make it to the details of a data set.
So I think where we could tweak the Schema.org process a bit and be a bit more explicit is on closing the loop when these things happen. And I guess Natasha's waiting for me to chase her, and I'm waiting for Natasha to come and tell me. But we want to get that back into the GitHub community or the W3C mailing list. And it's, when we hear these pieces of information, it's kind of a no-brainer to say, yep, that's used and useful, and it goes. And moving from pending into the core of Schema.org, it's not a huge difference. It's just kind of removing a little metadata flag that says, hey, this is new and exciting, or hey, this is new and wobbly. And says, we can still change it, but we think it's more or less done now. And I think with new stuff, similarly, build things and we can get it into Schema.org easily. If it's not got consuming code for it, but it's at least coming with a load of data, and I think the bioschemas work is rather in this category, then I think there's still a strong case to add stuff to Schema.org. But if you're publishing a lot of data that people are not using and consuming, there's maybe an alarm bell there too. So really, we want to be driven by people consuming the data.
Great. Thanks for that. So the next most popular question is for probably Natasha. I'll ask you first and feel free to kick it over to Dan. The question comes from Jeff DeLaBee from NCAR. He asks, any metrics on how often people A, discover geoscience data that has schema.org markup via just your plain search engine, and B, actually click through to the data set?
Right. So we don't have that information for the main Google search, but I'm assuming the question is for data set search. And we have recently published, I'll actually put in the chat in a bit, our paper at the International Semantic Web Conference with all the statistics. And there is a graph there. A couple of graphs in my slides were also from that paper. So geoscience, so we looked at the topics for the data sets that appear in search results. So as a proxy. And that's where I'm referring to also the joke in the chat that geosciences, need to beat out social sciences. I have to say that geosciences were a little bit farther behind there. It's about 10%. So about 10% of the data set that are returned for user queries are from geosciences. That's kind of the metrics that we have. But again, remember, the search engine is completely ecumenical, if you will, and there's a ton of data on any kind of topic.
All right, great. Yeah. Dan, did you have anything you wanted to add? Sorry, I didn't mean to cut you off there.
Not on that one.
Okay, great. Yeah, so we need to step our game up, geoscience data people. We're only 10%. We can do better than that, right? Okay. Maybe this next question is for Dan. Someone asks, so how do we develop schema.org software that isn't version dependent? Do you have any thoughts there or comments there?
Yeah, I was feeling a little guilty leading my overview of the software that's out there with kind of shaming two packages for doing it wrong. It was a bit mean, but one of them I have ended up maintaining because the colleagues that wrote it got reorged at work into another team and left it dangling. I think the basic thing is the schema.org data model is effectively the graph data model you know and love from RDF. You can also work with it with property graph tools like Neo4j or the Apache Tinkerpot project. So as long as you're working with it in a graph environment, its flexibility and extensibility are well reflected in your tooling. If you try to kind of treat it as a rigid definition of types and properties, you run into problems even if schema.org never evolved any further. So for example, if you wanted to generate the person type as a Java class and use schema.org to list all the properties that people can have, you can't stick anything else in there. You can't take Wikidata's blood type or star sign, whatever they've got for people, and add it in there. So you're losing a lot of the power and extensibility of the data model that you're working with. So yeah, don't do that. Or if you do that, understand the costs.
All right. Okay, so another question that is gaining some popularity. Natasha mentioned generating links between Google Scholar and the dataset search. Could you describe how best our community can provide this information?
Yes. So let me explain quickly how this works. And there's a very clear way how we can make this better, which has to come from the community. So essentially what we try to do is we try to find citations for data sets. So the link says, this data set has been mentioned in a paper, in this many papers. And as I'm sure you're all aware, dataset names or even URLs are not the best way to look for dataset citations. So the more we use, the community uses digital object identifiers and compact identifiers, any sort of identifier scheme that is persistent and easy to find, to sort of distinguish, the easier these links are going to be, right? Because if you think about it, if in a paper mentions a data set by DOI, it's very hard to mistake it for something else, and it's very easy to find. So I think, and again, DOIs are not the only way to do this. Compact identifiers is another scheme. Any scheme like that is fine, as long as it's persistent, referenceable, and unique for a data set.
Great, thank you. Hopefully we have some publishers in the room that heard that dataset DOIs are critical to this. It'll bring more traffic to your publications. Yeah. Okay, so Dan and Natasha, I'm going to paste the link into Slido in case you find questions there that are interesting to you. And maybe we can open it up to the floor if folks are brave to bring their questions up to you both here. Yeah, so I'll step back into the background and open it up here.
Adam, do we raise hands or so, or just?
I don't see a hand feature yet.
There is a hand feature, and I say maybe we have, hi everyone, Annie Burgess here. If we maybe have time for 2 questions from our participants, and then we can pivot into the exercise we have for the rest of the plenary time. So if you're using the new Zoom browser, under reactions, that's where the hand raise icon is now. So Pierre, was that you raising your hand? I'm guessing that was your voice that I heard.
Yeah, thanks.
Great.
So
Great.
briefly, I put that in Slido, but so Dan, I think you're already aware that in IOC UNESCO, we're engineering this ocean digital ecosystem for the regions, nations, etc., as part of the Ocean Decade. So we're using schema.org to help people push metadata and links to their data repositories. And we're being a bit more prescriptive than the usual definitions we have to be to build these systems. How do we make sure that that doesn't clash? And this is also to you, Natasha. How do we make sure that whatever we prescribe doesn't clash with something that shows up later in the schema.org specification?
Can you clarify the kind of prescriptiveness? There's this whole world of shape languages, Shackle and Shex. And that class of prescription is absolutely fine.
Mm-hmm.
If you are tweaking the definitions so that sensible uses of the current schema.org or the future schema.org will be inconsistent with your definitions, maybe that's a bit more problematic.
Yeah,
to be frank, there's a lot of wiggle room in schema.org. I mean, our person type, for example, I think we say alive, dead, or zombie. It's
right.
Narrowing it down is a fun thing to do.
It's the latter thing, because again, of that looseness of definition, we are, as far as we understand, compliant. But if that ever sharpens up or becomes more precise, we might not anymore. So I'm not sure about that strategy. I think that's a broader discussion, perhaps, but a concern of ours to lodge.
Should we go deeper on this? I think the last comment on that would be make public what you're doing, and we can blog about it in the schema.org world, for example, and make sure it's not something no one's heard of. And as long as awareness is there, then it'll get attended to in the schema.org change process. We can't promise never to change anything, but I think the first step is everyone talking.
Sure, we'll get our project manager to reach out. Thank you.
Thanks.
Great, thanks. I think, oh, sorry, Annie, I didn't mean to step on your toes.
Take it away. I would say let's do 2 more questions, Adam, and then our facilitator, Charlie, will hop in. So I will let you take it over.
Sounds good. So we'll have Doug Newman ask his question, followed by Nick Jarbo, and then we'll turn it over to the exercise.
So my questions are about dataset search. Will we be seeing a similar workflow between Google search and Google Jobs with dataset? Is that something that you have in your pipeline?
We are working on it. Stay tuned. It's definitely something that we think will be very compelling for those who don't know dataset search exists, so just kind of easier way to get to datasets.
I'm going to slip in my second one here now. Do you have any intention of utilizing schema.org search actions on landing pages? Because we have them in place for NASA Earth data. We think that's very useful for speeding up the time to getting users the data they want by transferring maybe some natural language parsable spatial context into a spatial constraint for Earth data search, for example.
Yeah, so that one, unlike the first question, this one we're not currently looking at, but it's not to say that we won't. I think that's actually a very good point. It could actually be very helpful. So not at the short answer is not at the moment, but I think it's actually something we ought to look at.
Thank you.
Nick, you had your hand up. Did you have a question?
Yes. I'm at a small paleomagnetic data repository And we have a data model where people put in their data in a very structured way. And it's much more difficult for people to do that, but that's what we sort of want. I was wondering, how quickly do these data sets show up on dataset search? That's a good motivator for people to do the extra work to get it into our system, where we have schema.org set up with lots of the variables showing up in the dataset search. And it's really cool to see your dataset show up on Google dataset search. But is there any way to push, we've got a new dataset, please include it, that sort of thing?
So I think the bottleneck for that is actually the Google crawl. So once the page is crawled, it will appear in dataset search in I would say at most 2-3 days. So the best way to make sure the pages are crawled, particularly in data repositories, because a lot of those pages sort of leaf pages, is to have them in a sitemap. And in your search console, you can actually say, have a new sitemap or request a recrawl of your sitemap. And sort of, you could have it generate automatically to have all the different data sets in there. And so and Search Console also gives you some feedback on how much has been crawled and whether there are errors and stuff like that. But once the page is crawled, so once it kind of gets into the Google ecosystem, it gets to dataset search very quickly.
Okay, we've got the dataset, we've got the sitemap set up, so we can look at that Search Console and see.
Because it's not been your experience, so have you published new data sets and it's been a while before they got in?
Yeah, but sometimes maybe our schema is not, it's ever changing, our schema.org headers and so on. So maybe sometimes something is going wrong with that too. So that's sort of an interplay that we have to see.
Okay, all right.
Thank you so much, everyone. Some great questions that we couldn't get to. Apologize for that. But maybe we could get Natasha and Dan to take a peek and provide some feedback on ones that interest them.
I was wondering if it's appropriate to answer them elsewhere in the ESIP schema group, for example.
Sure, that'd be great. Yep, absolutely. There's a mailing list. I believe, Dan, you're on it, so that'd be awesome. Yep, and we can make sure.
None of them seem particularly private. If someone's asked a question that you will be horrified to see asked in public, please say no.
We can also strip the names from the questions, just do the questions and our answers.
Pick up the themes at least.
Perfect. Thank you, guys. And that is the beauty of ESIP. Like, the work doesn't stop here, right? We have these meetings. We have 150 people on right now, but the work can continue throughout the year, and we want to find ways to encourage that. So thank you both. And thank you to everyone for all your fantastic questions. I'm actually going to turn it over now to our facilitator, Charlie Haley. They have an exercise plan for us as a group. We may be able to continue some of those great questions that Natasha ended her presentation with. And then we also would love to hear from folks about exactly that collaboration, keeping that collaboration going throughout the year, and how we do that. So I'm going to thank you to everyone and turn it over to Charlie.
Hello, everyone. And my partner, colleague is with me, Fisher Kwa. This activity, we're going to invite you to help each other. We're going to tap into some of your stories around what are the ingredients, what are the conditions that make for fruitful, generative, fun collaborations. When you think about, and for this part, you're going to need to take some notes for yourself. So go ahead and get out a document or a piece of paper to get ready to jot down some personal notes for yourself that you will use when we go to breakouts. So when you think about sharing your, Fisher, do you want to share the slides right now? Thanks. Okay, awesome. So when you think about sharing your thoughts, ideas, and efforts to advance this work and pursue bigger challenges together, what past experiences to collaborate come to your mind? These could be positive or negative, ones at work, ESIP, or some other place that may not be work related at all. What are the stories? So we're going to be tapping into what stories do you hold that could offer clues about what it takes to collaborate well with others. So I'm just going to give you a moment to bring up some of those experiences for yourself. Okay, next slide, Fisher. Thanks. So, in all likelihood, when you thought about that, you had some positive experiences and maybe some not too positive experiences. So when you think about sharing your thoughts and, oh, wait a minute, there we go. So if it was positive, what contributed to being a positive one? Were there particular conversations that you had that were beneficial, structures that you put in place, certain conditions that you may have stated up front with the other, agreements that you made, or some other ingredient that contributed to it being a positive experience? If it wasn't a positive experience, what might have been missing from your interaction with another that, that was missing or left untended, that if it were included, it would have made a difference to that collaboration? So take a moment and just kind of jot down, as you think about your experiences of collaborating, jot down any of these conditions or ingredients that you felt set you up to have a positive or not so positive negative experience. You may have had time to jot some notes for yourself. I'm going to hand it over to Fisher, and he is going to tell you what's going to happen in the breakout sessions.
Great. So what we're going to invite you to do is essentially, and maybe part of the context for this is, you know, the two presentations really set such a lovely way of thinking about, like, what are the macro factors that sort of enable these very diverse long-term collaborations across like scientific disciplines, and now we're trying to zoom all the way down into like, and how do you pair those things with individual practices, behaviors, and other things that really enable and invite people to work together successfully. So in breakout rooms, what we'll invite you to do is briefly describe, like, just maybe one of the little anecdotes or stories that came to mind. Just share a really, really brief example, one at a time, of a story that you thought of, whether it was positive or a negative example. And as you're listening to each other, try to help really pull out the ingredients that contributed to those stories, and don't ignore or overlook some of the crude, messy, imperfect details of those stories as well. And once you've had a chance to hear all three of the stories in Kiko chat, if you move over to from the Q&A on the Slido poll over to polls, there's a place to just enter some of those ingredients, and you can enter them either as individual words or as phrases. And what we're trying to essentially pull out of all of the varied experiences people have is kind of a shared list of the behaviors, practices, attributes, sort of the enabling conditions for these kinds of successful collaborations that everybody's working towards. So as we go into breakout rooms, as sometimes happens, if you happen to find yourself alone in a breakout room, you can either sit there and think to yourself what you did to deserve that fate, either happily or unhappily. Maybe like, oh, thank gosh, I'm alone. I feel so great. Or come back to the main room and we will quickly find a new partner for you. So either way, you're welcome to either stay in the room on your own or come back and we will find a new group for you. Charlie, how long do you want for these breakout rooms?
I think we gave them, let's see, do we have 15? No, we don't have 15 minutes. How about 10?
Sure.
10 or 12.
Cool. Let's do that. We'll do this. We'll do that. And we are on our way.
Can you stop sharing now?
Yep.
Do you want me to put you guys in any rooms?
No, I got the breakout rooms set up.
Oh, did you do that?
I did.
I was like doing the same thing. No, it's okay. I was opening breakout rooms and then I pressed the breakout rooms and all of a sudden they all started opening and I was like, oh my gosh, did I enable something really quickly? So,
Did
okay.
we literally, sorry, we should have coordinated that.
No,
I did
that
not
was
mean to
totally
freak you
fine.
out.
I didn't know if co-hosts were able to set them up. So that's great. I don't have
I
to
didn't think co-hosts could, and now I see they can.
Good.
I'll go join a room that only has 2 people in it.
Yeah, I'll go look around too. Let's see.
Dawn and Jonathan, did you come back out of empty rooms?
Yeah.
Okay. I'm going to put you.
Don.
Okay, I'm going to do that. I'm going to do exactly that. Let me just move you two together. And so Don and Jonathan, I think at the bottom of your Zoom screen, there should be a little breakout rooms button. And if you click that, you have to manually say yes to going back into the breakout rooms. Cool. I think they're mostly people are settled. Oh, Kim Valentine's alone. I will move Kim.
I also see in room 3.
I just put
perfect.
Kim with
Awesome.
with them. Yep.
All right. Nice. 022. Adam. 222.
Karen.
Apparently, there were a couple of people, but I think they were away.
Oh, away. Okay.
Yeah.
Let me. Emilio's there. Okay, Emilio, you and Karen are going to be together. Okay.
Okay, I was coming back here because I was alone.
Yeah, I just saw that. Looks like somebody just dropped. Okay, so Emilio, at the bottom of Zoom, there's a little breakout rooms button. If you click that, it'll ask you to confirm and it'll just drop you back into your room with Karen.
Okay.
Daniel, were you all alone? Did somebody abandon you, Daniel?
People have been abandoning me all my life.
Oh no. Where were you? Let me see. I'm trying to pull you up, see where you were.
I actually just came back in. I had to go off into a
Oh. Okay.
No. So are we in breakouts?
Yeah, we're in breakout rooms. Did you hear the instructions or what people are doing?
No, I better just stay out here and socialize.
Well, Cynthia, looks like Cynthia just came back because maybe was left alone by a partner. Daniel and Cynthia, do you want to hang out together and chat about the conditions that enable successful collaborations?
Sure.
Cynthia, are you there? I can't tell. It looks like you came back, but I'm not sure if you came back intentionally.
I'm really good at BSing on things that I have no background.
Okay, Daniel, I'm going to drop you in with a couple people then, and you can just absolutely go do that with them. Okay. Is there anybody you want to be with, Daniel? I can.
No, I'm fine with anyone.
Okay.
I like irritating everyone.
Okay.
Did Linus's question get erased from the poll? I was just trying to look for my link that Megan sent the other day and I can't find it.
Linus is, yeah, I don't see it, so I don't know.
I think Megan may have gotten rid of it.
Okay.
Lori and Rob in room 23 want to be moved with more people since there are only 2. So I'm going to, oh wait, maybe they're in room 24. I'm just going to move them to room 23 with
Cool.
Chris. And,
people like, I just don't want to. Cool.
Woo! Down the rabbit hole.
it's the anxiety of being with one other person. Lori said, she's like, I just don't think I have enough to share to only be with 2 people. So I said, oh. Okay. Let me see. Okay, they're all together.
Have you guys checked out the word cloud in Slido yet?
I haven't. I have to go. Oh, sorry. My husband is yamming in the background here. I'm going to go look over there right now. Okay. I'm looking at it right now. Sharing stories and anecdotes, descriptions, ingredients.
I'm not seeing them, Charlie, are you?
No.
I'm seeing them.
I see that 16 people are.
You don't see all the words though?
Mm-mm.
I can see the words. Let me just like toggle out and then toggle back in. Did you guys add your responses? Maybe I see it because I added a response.
Is that we have to add?
Yeah, I think that's it.
Got it.
I kind of like seeing this evolve in real time.
So Charlie, what I thought we'll do is just have them review the word cloud and think about the ingredients they came up with and then just respond to those prompts in chat.
Yeah, the ones that you came up with yesterday.
Mm-hmm.
Yeah.
No. I love in Zoom the people that like immediately abandon by just not even waiting for the 30-second countdown time. They're just like compulsive clickers. I feel like everybody who just came back is a compulsive clicker. Something pops up, you're like, oh, I got to click that.
Where's my treat for clicking the button?
I know there. Yeah, I mean, you got the dopamine treat. That's what it was, Carl. Your brain is giving you the dopamine treat right now for having clicked early.
I'm drooling.
You know, I do miss the hot beverages and baked goods of a face-to-face meeting.
Yeah, Leslie, it's like you click it and then you realize you abandoned your partner and you like have that horrifying moment of like, oh no, what did I just do to my partner in the middle of what they were saying? I always have that moment.
Trust me, Carl, if I could cost effectively send you baked goods, they would be at your doorstep right now. But yeah, there's not a cost effective way to do that. It also doesn't have a great carbon footprint. So I decided no. Make your own.
Well understood.
No
we've
ESIP
been having
takeout
the
yet.
same discussions for our monthly workshops where we traditionally provide donuts and coffee, and we just can't do the same thing in our virtual versions of them.
I'll make that a plug. We will talk about committee assignments tomorrow and later on in February. But if you're interested in the meetings committee, that could be a place for you.
Well, you can stimulate the conference feel by just picking up your own snack and throwing $20 in the garbage.
Okay.
There you go.
So as you came out, there's some really lovely contributions in the Slido. And maybe just for a moment, take a look at some of those things and think of the ones that your own little conversation group just came up with as well. And just in chat, we're going to have three quick prompts. One is like, when you look at these ingredients, is there one that for you is just a little bit more difficult or complicated to pull off? Like, you know, for me, I can often struggle with being patient. Like that's one that I like personally. Like I don't have it all the time. Or, you know, so look at that list, and is there one that for you just personally is more challenging, more difficult to pull forward to implement successfully?
Patience.
I'm with you, Ben. Or Beth, sorry.
That's okay.
Is that your dog's name is Patience? Or are you asking the dog to be patient with you?
No, I'm reading the list and saying patience is the hard one, is often the hard one to.
Yes. Denise, did you have something you wanted to briefly comment on?
One of the things that we talked about, and I see kind of in here, is respect, particularly around differing opinions. That can be a challenge, particularly when people get very passionate about things. But I think it's actually something I think ESIP does very well. So.
Cool. And then just the last one, as we're sort of transitioning out, if you think about this list of ingredients as a leader yourself, as somebody who's working pretty frequently in teams or collaborations, is there one of these, you don't have to add this in chat if you don't want, but one that you just like, you know, I want to focus on my practice in that area, or I want to develop my own awareness or my own work around, you know, how to build trust successfully, or how to do exactly what was just described by Denise, like how I help people hold their strong opinions in a very like sort of respectful way. So just look for one that maybe is like, that's an area of growth or an opportunity for me to develop a practice around it. And with that, we're going to transition over. Charlie, anything else you want to add before we transition over to Susan to say goodbye and take us to what's next?
No, I think that's a great way. I love this little word cloud. Great way to end. Thank you.
Well, thank you, Charlie and Fisher, for leading us through that. I think it's just really fun. I had conversations with two people I haven't had a chance to talk with much before. One, a longtime ESIP member, and one, a first-time attendee. And that's what it's all about, right? So we have an hour break now before our afternoon breakout sessions. I thank all of you for sticking with us. It's always interesting for me. I think we had over 170 people in the plenary, but we had over 60 of you that stuck with us through the exercise. Thinking about effective collaboration, I mean, that's always been part of ESIP. One of the recent challenges I'm hearing, but I don't think that probably isn't that recent, is cross-cluster communication. And how do we enable that cross-ESIP collaboration? And so I know our team is really thinking hard about that for 2021. So this input helps with that. And I thank you for your inputs. And we will see you in breakout sessions at 1:30.
Great session. Thanks, everybody.
Yes, we go.
Bye.
Thank you.
Bye, everyone.
Thank you. Bye.